In this video, I've tried to explain the basics of the PID controller. Let's go one by one. First, let's have a look at the inference of changing just the proportional value. I've taken an example of a driving simulator which is controlled by a PID controller. Say suppose my driving simulator needs to follow a constant velocity profile, in this case say 20 kilometers per hour. If I give a correct proportional gain, what happens here is my curve follows this trend and it's very slow and there's no steady state error in this case. But there's a high chance of me giving an increased proportional gain. In this case, it overshoots and gets back the same proportional gain in the negative side. So it keeps going and it oscillates back and forth. So this basically results in a very unstable control, as you can see from the graph. So that's the main reason of having the D value inside the controller. Basically, the D value differentiates the error and let's have a look at an example. Let's say suppose I need to park my car inside my garage and the position of the garage is shown in the graph. Say suppose I give a overshooting proportional gain. The same thing as explained in the earlier case, it overshoots and keeps oscillating back and forth. But say suppose I differentiate the error and give a D value corresponding to that. What happens is my rate gets decreased and the curve tries to settle down at a faster rate, as you can see from the graph. So to conclude, p value just multiplies a proportional value to the gain, and the d value controls the rate at which the change occurs. But is it enough? No. Now say the parking garage is not stationary, it's moving with a velocity v. So what do we do now? Let's have a look at an example. With just the P and D, at some time I'll eventually stop at the garage, but maybe because of the D value at a slower rate too. Say suppose I have a garage and a car, and I try to park inside the garage. It's fine with the P and D and the garage being stationary, it works. But what if the garage itself is moving with a velocity? Now the P and D don't eliminate the steady state error, and the oscillation still prevails. What happens is once it has entered the garage with a P, it tries to go back and forth, and the D may be at a slower rate, but the steady state error is not eliminated. So we need to have an integral control for this. This basically calculates the area under the error curve. Area never can become zero, so there's always a value which is given to the error, multiplied to the error and given to the control system. So by this way we eliminate the steady state error.